Question number 3. Let's solve this system of equations. I will solve this system by elimination. And to do that, we want matching coefficients for either variable. So I will actually multiply the top equation by 5, just so that I get a negative 10y, because negative 2 times 5 is negative 10. And the equation below, the bottom equation, I can just multiply by 2. So 5y times 2 would be 10y. So let's do that. 5x times 5 is 25x. Of course, we need to multiply every element by whatever number we choose to multiply the equation by. So negative 2y times 5, negative 10y. And 15 times 5 is just 75. Great. Now down below, we're multiplying the bottom equation by 2. 4x times 2 is 8x. 5y times 2 is 10y. And 12 times 2, 24. Okay. Now what can we do? Well, we have negative 10y and a positive 10y. So if we just add these equations, negative 10y plus 10y is 0. They would just cancel out. A common mistake, or a very common mistake, would be actually to subtract in this case. But in this particular case, subtracting would not be a good idea. Why? Because if we did negative 10y minus 10y, we would get negative 20y. We don't want that. We want to eliminate the y's. So, continuing, 25x plus 8x is 33x. And 75 plus 24 is 99. At this point, we can divide both sides by 33. And we get x is equal to 99 divided by 33, 3. So that is the value of x. Now, how can we solve for y? Well, I can just plug in 3 for x in either equation, and then solve for y. So let's do that with the second equation. So 4x, and x is 3, plus 5y equals 12. 4 times 3, 12, plus 5y is 12. I can subtract the 12 from both sides of the equation. So I get 5y equals 12 minus 12 is 0. I can divide both sides by 5. And 0 divided by 5 is just 0. That's it. Great. So now we always have x comma y. X is 3, y is 0. So the solution is, or the answer is D. 3, 0.